Dear students, today we are going to discuss about interconnection of two-port networks. There are two types of interconnections. First one is series connection, second is parallel connection. In this video, we are discussing about series connection of two-port networks. So for connecting the networks in series, we are taking two-port networks. First network is X, second network is Y. See here the interconnection is shown. Before interconnecting, the X was an independent two-port network and Y is also an independent two-port network. You know that in the two-port network there will be input port like this and output port like this. Similarly for an independent Y network, independent two-port network Y, there will be input port like this and output port like this. And we know that in the case of two-port networks, there will be reference node for each port. In the case of input port for this X, the reference node is this one. Similarly for the output case, the reference node is this one. In the case of Y network, the input node is this one, and in that reference node is, we are taking someone is reference node, that is let it be this is the reference node. And similarly for the output for the Y network, there will be some reference node and the reference node is this. For series connecting two-port networks, we are interconnecting the reference node of each network. You can see here X and Y are two independent two-port networks and we are interconnected the reference node of X with Y. Similarly, input reference node of X with input reference node of Y. You can see the connection, okay? So, here the currents and voltages are marked as, here I1 is the input current to this X and I2 is the, considering to first network, I2 is the output current for this network. Similarly, here also there will be some current for this network Y that is given through this and output is taken through this. Since for interconnecting we are using two reference nodes, so that connection is shown like this. So then we can mark the input as, see now this is a series connection. So we can represent the input current as I1 and here also the input current is in this manner and here the current is I2 and here the current is in this manner. So we are representing, here there are two networks. So we are representing the components of the current as I1X, here it is I2X and here it is I1Y, here it is I2Y. That means I2 is composed of two components, I1X and I1Y. Next, we can mark the voltages, that is for X network voltage is V1X, here the voltage is V2X. Now the voltage is V1Y here and this is the voltage V2Y here. And here the input voltage is marked as, after the interconnection, the input voltage is marked as V1 and here the voltage is marked as V2. So now we have, for the series connection, total voltage is V1 here at the input side and for the output side, the output voltage is V2. Okay. So this, for the series connection, this is the input port and this is the output port for the series connection. Okay. Similarly, we can find the current I1X passing through this and it will go to this network like this. Okay. And then we can take the output. Okay. So let us write the equations for this. Usually for the series connection, we will be using impedance parameter representation, and for parallel connection we will be using admittance parameter representation. So here we will be using impedance parameter or Z parameter. So we can use the equations as, first of all, in the case of impedance parameter we will be representing V1 and V2 in terms of I1 and I2. So here there are different components such as X and Y components for voltages. So we have to write the individual equations. So first of all we will write V1 equation, then we will write V2 equations. But here V1 has component X and Y, so we have to write the individual components like that. Okay. So if we are taking the first network X, then corresponding to that X network we can write V1 X equal to, we know that it will be written in terms of I1 and I2, so it will be Z11X I1X plus Z12X I2X. Similarly for V2X, that will be equal to Z21X I1X plus Z22X I2X. And this is for the X network equation. See, this is the X network. So we are writing the V1X and V2X in terms of I1X and I2X. So next we are taking the Y network. So we are individually writing the voltage equations, that is V1 and V2 in terms of I1 and I2. Here for the Y network we are assuming that the currents are I1Y and I2Y and voltages are V1Y and V2Y. So we can write V1Y equal to, in terms of set impedance parameter, that is Z11Y I1Y plus Z12Y I2Y. Similarly V2Y equal to Z21Y I1Y plus Z22Y I2Y. Here there is no confusion because we know that we are taking X and Y network individually and we are writing the equations. V1 is the input voltage, V2 is the output voltage for the X network, and V1Y is the input voltage and V2Y is the output port voltage for the Y network if we are considering the individual ports. Now after we are interconnecting these X and Y networks, we have to see, we can see some relations such that here the currents and voltages are marked here, and here V1 is the input port voltage of this series combination, V2 is the output port voltage of this series combination. Similarly, we can see here that here I1 is the current, input port current. Here I1 is given through this port. So you can see here that I1 equal to I1X here. Okay, right? I1 equal to I1. Similarly, there is another current, that is I1, that is equal to I1Y. That means we can see that I1X, if we are considering the complete combination, we can see from here that I1 equal to I1X and I1Y. So you can write I1 equal to I1X equal to I1Y. Similarly, when we are going to the output port side, you can see that I2 will be equal to I2X. That is similar to I2 will be equal to I2Y. So you can write I2 will be equal to I2X equal to I2Y. So this is the current relation. So in the case of series combination, we can replace this current I1 and I2 instead of I1X and I1Y, because the currents are equal in the case of series connection. And now when we are going for the V1 case, we can see that V1 is the port voltage, input port voltage. You can see that for the series combination, this is the sum of V1X and V1Y, right? You can see it from the figure because it is the voltage across this port and this is the voltage across this port. So V1 will be equal to sum of these voltages, right? Similarly, when we are considering the V2, that will be the sum of V2X and V2Y, right? So you can write the equation V1 equal to V1X plus V1Y, V2 equal to V2X plus V2Y. So if you are seeing the equations, this is V1X, V2X, V1Y and V2Y, you can replace the equation as V1 can be written as V1 equal to Z11X. Instead of I1X, you can write I1 plus Z12X. Instead of I1 to X, you can write I2. Similarly, plus instead of V1Y, you can write Z11Y I1 plus Z12Y I2. Here you are replacing I1X and I1Y by using I1 and I2X and I2Y by using I2, and you are actually substituting for this equation. You know V1X and V1Y, you have written the equation. V1X is this one and V2X, V1Y is this equation. In both these equations, you can substitute for I1X and I2X, I1Y and I2Y. So you will get the equation like this. In this case, you can take in this term and in this term I1 is common, so you can take I1 outside. So you will get V1 equal to Z11X plus Z1YY into I1 plus in this terms you can take I2 outside. So Z12X plus Z12Y into I2. So this is the equation for V1. that is, this is equation for V1 when the two networks X and Y are connected in series. So from this relation you can see that the impedance, see this represents Z11. So you can replace V1 equal to, in the next slide, V1 equal to Z11 I1 plus Z12 I2. Here Z11 is this Z11X plus Z11Y. Similarly Z12 is Z12X plus Z12Y. That means the Z parameter of the series network is given as the sum of the corresponding parameters of the individual network. Similarly, we are taking V2 equation. V2 equation is this. V2 is V2x plus V2y. You can substitute for V2x and V2y from this. That is, V2x is this equation. V2y is this equation. When you are substituting that equation, you can find that instead of I1y and I2y, you can put I1 and I2. So you are substituting that. And even you can take I1 and I2 commonly outside, you will get V2 equal to Z21x plus Z21y into I1 plus Z22x plus Z22y into I2. Here it is not x, it is Z. Okay, that is a mistake. So you can write from that equation V2 will be equal to Z21 I1 plus Z22 I2. So what is the meaning of this Z21? Z21 will be equal to Z21x plus Z21y. Similarly, what is Z22? Z22 equal to Z22x plus Z22y. So here also we can say that the Z parameter of the series network is given as the corresponding parameters of the individual networks. Okay, that's all about this topic. See here, in the case of series connection, the Z parameters when we are connecting two-port networks in series, first of all we have to write the individual equations for first network and second network. Then we can formulate the combined series network equations. Okay, for this combined series network, the Z parameter will be the sum of the Z parameters of the individual network. That is the speciality of the series network. Okay, for analyzing the series network, we are using impedance or Z parameters. Okay, thank you.